So thank you so much for inviting me to talk to you all today about archaeological applications of LIDAR, one of my favorite topics. So for those of you who don't know very much about LIDAR, I thought I'd give a very brief introduction. So LIDAR is an active remote sensing method. It is used basically to create really detailed digital models of the shape of the surface of the Earth and objects on it. So the way that this works is that you put a laser scanner, which is basically a machine that sends out a laser impulse, which then bounces back off the surface of any object it encounters, and that signal is recorded when it bounces back. So you put one of these laser scanners normally into an aircraft. So there are lots of different types of LIDAR, but today we're talking about the aircraft mounted type. And you fly this scanner across the surface of the Earth, which is what we see here in the diagram. And you collect lots and lots of measurements of the surface of the Earth and objects on it. So trees, houses, small sheep, whatever is hanging about. And you then take this collection of measurements and you use it to create your digital terrain model. So this is just another view of the same explanation that I've given you. You fly your aircraft across the surface of the Earth, taking all of these different distance measurements, and you essentially end up with a whole collection of XYZ coordinates. So location plus elevation, and this is normally then visualized in something that we'll call a point cloud, which is what you hopefully see down here. And this point cloud is a really interesting remote sensing data source for archaeologists, because what we can do with it basically is we can manipulate it digitally. So through a process that we call classification, where we assign different points to different types, we are essentially able to separate the points from the surface of the Earth, so from the ground, from the points from the returns that have come back from vegetation, sheep, houses, other things that are hanging about on the surface of the Earth. And what this then allows us to do, which is really interesting archaeologically, is to essentially get rid of all of the buildings, get rid of the sheep, get rid of the trees, and to see a model of just the surface of the terrain, just the topography, which we can then manipulate visually in different ways, which I'm going to talk about in a moment. And so for archaeological purposes, what we're really interested in with LIDAR are these very, very detailed versions of the model of the surface of the Earth. So ones where we have, normally we'll say kind of 16 points per square meter on the ground is about what you want for archaeological work. So this is a very high-res spatial resolution data set, if you think of the spectrum of resolutions that Dr. Tabang was talking about earlier. Now, one of the nice things about LIDAR for archaeological research is that we can digitally manipulate these terrain models that we obtain. And there are lots of methods for doing this. I'm just going to show a couple here this morning. So one of the key things we do is we simply manipulate the way that light, an artificial light source, is cast across the surface of our digital model of the Earth. So here you see a model of a set of fields with what are referred to as ridge and furrows. This is kind of evidence of past agriculture. And we have the light kind of coming from the top left in this version, so 315 on a circle from 0 to 360, and 45, so 45 degrees from the surface of the Earth as an angle. And you can then say, okay, well, I want to see the light from a different angle. So you can move the light digitally to a different position, so say to 45 degrees on the clock, and hopefully you were all able to see that the features that are visible, the archaeological features we're interested that are visible on the surface of our digital terrain model, change as we manipulate the location of the light source. So as a source of remote sensing data, this is really interesting to us because we can pull out detail by manipulating the digital terrain model. So that is just one way that we visualize a digital terrain model. Another way that we might visualize it, so that first one is called a hillshade. This is called sky view factor, which essentially does kind of what it says on the tin, in that it is a calculation of, if you were standing at any given point on our digital terrain model, how much of the sky you could see. So if you're on the top of the hill, you can see a lot of the sky, and you're going to get very kind of bright values. It's kind of visualized as a bright point on your digital terrain model. And if you're in the bottom of a well, you're not going to see very much of the sky, and everything is going to be very dark. And so this model allows us essentially to, once again, visually pull out lots of detail of what we can see archaeologically in the digital terrain model. So hopefully you're seeing lots of squiggly lines, lots of features that represent, in this case, the remains of a complex of buildings. So this digital terrain model is a really rich data source. Now, we have literally dozens and dozens of ways that we can visualize the terrain model. And what we then do archaeologically is we go through and we interpret what we think we can see in the model. So it's a visual interpretation practice where we say, okay, you know, I think that that feature looks like the upstanding remains of the wall of a building. I think that that feature looks like the remains of a field system. And we then in GIS normally are going through and drawing the shape, the extent of these features. And this is really a method of working with remote sensing data that has deep roots in certainly the UK and European tradition in archaeology of working with remote sensing, in that we interpret our topographic evidence on the basis of both seeing it from above, so from aerial photographs traditionally, and from work on the ground. And there's a long, very rich tradition I won't go into today of how we draw and depict these features. And what's really interesting with LIDAR at this point is that we are essentially taking this set of practices and we are translating them to work with digital data. So we're taking everything that we've done for more than 100 years in the field, and we are learning to do that same kind of topographic interpretation with our digital terrain models from LIDAR. And so there are lots of interesting implications of this. Now, one of the main archaeological impacts that I want to run through with you is its impact on our ability to survey in forests. Now, I glossed over this previously, but that bit where we can classify the point cloud and separate and remove the points from the trees basically means that we can see in immense detail the shape of the surface of the earth preserved under forest. And this is huge for archaeology because most other remote sensing data sources do not allow us to see through the tree canopy. So this is why archaeologists are very excited about LIDAR. We really enjoy it. And as I probably do not have to tell you, much of the surface of the earth is in fact covered in forest. So this is a really important remote sensing data source. I will note that nice chunk in the center of Africa where there are not a few forests. And LIDAR also allows us to see these same kinds of topographic features in areas with shrubs and grasses, which again are less amenable to a lot of other remote sensing methods. So one of the really big things that has happened with archaeological LIDAR is it has really changed the position, changed our ability to comment on what is going on and to get involved in debates on the impacts of deforestation, afforestation, and forest management, which, as you all know, are really entangled with contemporary debates on everything from mitigating climate change to the changes in agricultural strategies and where cultivated areas are and how public perceives the forest. So this is all really quite important. So this is a remote sensing method that I would say over the past 10 years has really changed the public perception of today's forest and is the key method for archaeologically investigating the cultural heritage of forests, understanding the length and character of different impacts on land uses, and really promoting forests as being really active economic and social landscapes. So this is an archaeologically important remote sensing data source. So what kinds of things do we see with it? All sorts. We see everything from boundaries that represent old field systems, which are these linear features you see here, to clearance cairns, which are these little bumps, and then these features that kind of are circular and have kind of a dark bit on one side and a light bit on another side are charcoal burning platforms on a hill slope. And these are all things that we have kind of learned to recognize archaeologically in the data. So we end up being able to build up really multi-phase topographic palimpsests. So features that we recognize as belonging to different periods that are aggregated under the forest cover. And this, again, archaeologically is really interesting because it's giving us insight into changing land use, different activities in the same area over time through this remote sensing data source. And so these are examples from the forest Chailloux, which is in Central Eastern France, where I've worked in my own projects. And what these aggregations of features really let us get at are very locally specific pictures of things like patterns of afforestation and deforestation. So what you have here is a series of fields. You can see the field boundaries. You can see all of those little bumps. Those are all clearance cairns. So you see very clear evidence for past agricultural land use in an area that is now forested. So you can see through this remote sensing data set us building up a picture of what is going on in terms of long-term land use change in this area. And these features are really quite difficult to see and recognize on the ground as you're walking around. So I've kind of drawn over one of them there. So this is really an important thing for us because even if we were able to go on the ground, we wouldn't be able to necessarily see very clearly all of these features and how they relate to one another. So archaeologically, this is very important for us, and we can start to pick out, using this remote sensing data, fairly direct relationships between features that represent these different activities, which will sometimes physically intersect, physically overlay one another. And one of the things that has really emerged from all of this is just the huge extent of evidence for long-term forest economies and intensive phases of active forest management. So you see here, all of these green dots are charcoal burning platforms that were located in one area of the forest Chailloux. The little purple triangles are then lime kilns, which are probably also exploiting the woodland resource. So the number of sites archaeologically that are known in forests have absolutely exploded in the years since LIDAR came on the scene. And this then allows us to really target our survey work on the ground and investigate past forest management through things like strategic sampling. So this also allows us to compare different regional trajectories. So we can take what we're seeing in the forest in Chailloux and compare it with the trajectory of land use patterns in Châtillonnais. So with our colleagues' work, which is also revealing huge complex field systems with evidence of occupation 2,000 years ago in an area that is now heavily forested. So I've been emphasizing the forest impact, but just to say, to remind us as well that this also lets us see what is happening in unforested areas. This is a nice example from Arran, from an upland area under kind of rough grazing and heather, where you are seeing, again, preserved evidence. This is what we see down here of past pastoral activity, so keeping of animals, that is no longer what is done in this landscape, but that evidence is preserved and is visible in the LIDAR data. So just to wrap up, what are the implications for some of this now as we are developing research and management strategies using this remote sensing data source? One key thing is that I think it's really pushed us towards mapping activity and land use areas rather than features and sites, and I think that's really where archaeological remote sensing with this data source has gone. One thing that I know you're going to be engaging with in this project is getting ourselves on a landscape footing. So scaling up and employing machine learning methods, which are increasingly used in remote sensing broadly writ, but there's a lot of action around this looking at archaeological LIDAR. There's an excellent project run by my colleague, Dave Cowley at Historic Environment Scotland, who's been leading research employing automation and machine learning on Arran using the LIDAR data there, and really asking what happens when we can't look at everything and what happens when we change our focus from looking at individual sites to hold landscapes, and we're really scaling up and looking at larger amounts of data, which again, I know is something that this project and this research community are going to be engaging with. And this is absolutely critical. And again, my colleagues at Historic Environment Scotland have done some quantification of how long it takes on the ground to work to cover and conduct archaeological surveys on some of these areas. So, you know, you can spend literally, as you see on the slide here, hundreds of days, tens of days to hundreds of days trying to do this survey work. And so this is kind of okay if you are in a sites and monuments management framework, but it's not really okay if you're trying to look at the whole landscape and look at landscape change. You really need to be able to scale up and go faster. And so that is where these studies on machine learning and their use to let us investigate patterns are really coming in. So I'm aware of time, so I'm not going to go into any more detail on that, except to say that this is really the thing that is changing our survey practices today and what we're really going to be engaging with. So I will wrap it up there and leave time for a few questions.